Kia ora. I'm Jochen Schmidt, Chief Scientist of Environmental Information at NIWA, and I want to talk today about the problem of sharing environmental observation. And I want to share with you my view on what we need to do as a nation to make this process easier. So let's look at the problem. Let's start with a clean slate and look at how we share environmental observation traditionally. Assume we have a guy called Jack who needs some data. And he happened to know a guy called Don, who he assumes has some data. So he used a very traditional method to communicate with Don, the telephone. Don, after some research, has some data and promises to send it through. After a while, maybe 10 minutes, maybe longer, a data set gets through to Jack. Now the second problem of interoperability exists. Jack needs to understand the data. He needs some more metadata. Where's the site located? And luckily enough, Don can provide that information. But we need more information. What are the coordinates? What is the reference system? And then even more, what about the sensor, the method used to capture the data? Oh, it's calculated from a stream gauge reading using a rating curve. How accurate is this? And we run even more and more into problems. Now, this is a very simple description of how we access environmental observation. In real world, much more processes can be involved, and the process can be much longer in terms of from data discovery to data reuse. So let's look at how we want to share environmental information in an ideal world. Again, we have Jack. He wants some data. And he has a magic button in this case. And this magic button does three things. First, based on the specification of Jack's needs, it finds all data sets automatically which match that need from different providers. Secondly, it sucks the data directly into Jack's system. And thirdly, because the system understands the data, it combines the data into one seamless data set, and Jack is a happy man. So when sharing environmental observation, we're talking about three essential steps. We need to be able to find the data. We need to be able to access the data. And thirdly, we need to be able to understand the data. And all of this needs to be supported by consistent communication protocols. And when I mean consistent communication protocols, I'm talking about ways, standard ways, to ask questions, to query the data, and to get the results. So let's explore a bit more in detail on what we need to enable sharing of environmental observation on those three steps: discovery, access, and understanding. And I will use the NIWA Water Quality Data Services to explore that. For discovery, NIWA provides the data catalog, the NIWA data catalog, which is queryable in a standard communication protocol called Catalog Services for the Web. In this case, I constructed a query for water quality observations, which looks like this. And I get a response, which looks like this. And because those are based on standard-based protocols, I can render the return from the catalog in a client, for example, like this. And it displays, and I can see it displays some basic metadata, some abstract, some title, some geospatial location, some contact information, and also some links to related resources like a data service, measured parameters, and a location service. Is this good enough? First of all, to get the data, you need to understand about the NIWA data catalog and where the data is. And while this catalog is also linked to other data services like the geodata service, geodata.gov.nz, and can be discovered through this one, this is just a start. What we need for sharing of environmental observation is a well-maintained national registry of service endpoints, so people can query across different data holdings, across different data providers. Secondly, we need to agree on a standard metadata format. Here we used a particular one, and I'm not sure how this particular protocol which NIWA used fares with the protocol in other providers. Some more work is to be done here in terms of providing guidance for data providers, providing training, and also auditing in terms of standard metadata protocols. Thirdly, in terms of the content, we need standard vocabularies to enable meaningful queries. For example, in this case, I used the term water quality observations to query data from the NIWA data catalog. And I was able only, of course, to get an information because I asked the NIWA data curator to add this particular term into keywords for this particular data set. What we would need to enable cross-agency discovery of data is standard vocabularies which are used across different agencies, which again need to be maintained by some national agency. And finally, we need to define and to standardize how we deal with related links to related services. In this case, we basically added some online resources which we gave a URL and a name, which means still people have to read this and to make a judgment call on where to go to find more information. We would need standards, probably vocabularies, in order to enable that in a machine-to-machine readable way. So let's move from data discovery to data access. In the NIWA data catalog entry for NIWA water quality data, there is a data service referenced, and this is the call for the data access service. It is based on a standard WFS web feature OGC web feature service, and if you query it, if you put it in your browser or in your client, you get an answer like this, which again is consistent with the OGC web feature service, and which provides lots of data about what observations have been made at a particular site at a particular time. And you can of course then render this as graphs or tables. So how does this fare against standards? While NIWA used the web feature service, which is a standard communication protocol, this format is actually not suited for data transfer. We would need, for the particular case of water quality information, a standard communication protocol. As you can see over here, for example, we used very made-up names, very made-up markups for transporting the data. So we would need a standard communication protocol, probably around source time series as well, but this is to be explored. Let's look at the last part of data sharing, at data understanding. As part of the catalog service, we specified a vocabulary of service for explaining the parameters, and this is this URL, which again is we use the web feature service as a communication protocol, and you get this response, which for each of the XML constructs which we saw in the data service provides a simple term which explains what the parameter means. Now, while this is quite nice, it doesn't follow an appropriate standard. Web feature service is not really designed for communicating vocabularies, so we need a standard, a national standard for how to explain data, for how to transport vocabularies. And most importantly, while each agency can stand up its own vocabularies, we would need national vocabularies which are well maintained, so that clients can search across different data services, across different agencies. So in summary, what do we need to enable environmental information exchange in New Zealand? We said we need consistent discovery, access, and understanding data. And digging in more detail, we saw that in order to enable discovery, we need an agency to take responsibility for metadata services standards about the dataset, which includes, by the way, training and help for data providers, and auditing services, providing feedback to data providers how they fare in terms of complying to that standard. Related to this is also we need national catalogs and registries of service. Think telephone books, where I can find across different agencies what information is there. In terms of access, we need standards for data services, which probably are domain specific, depending on data type. Biological data might require a different standard than time series sensor data. That is to be explored. In terms of understanding, we need standards to be established for how to use vocabulary services. And we most importantly need the maintenance of national vocabularies for data properties and metadata such as methods, observational parameters, data processing, etc. In addition to that, we need a standard for how to link the above services to each other, so that when, for example, finding a data set, I directly can access the data and can find more information, or when accessing data, I can find more information about what the data actually means. As part of the National Environmental Monitoring Standards Project, the NEMS project, we have started to draft a document about the general architecture for how this should look like. But in order to make this happen, different agencies across New Zealand need to take ownership, need to take leadership, need to provide resources to make this happen, to enable different agencies, to support different agencies, to make the data available to standards, to provide national vocabulary services, and to provide national registries, so that we can all work together towards the dream, towards the reality of making environmental observation sharing easier.